So hello and welcome to yet another video. And today we have something special. This is not the usual kind of mainboards that I fix. This is a service style mainboard and I've never worked on one of these before. This is AM4 based and it looks very interesting. It uses DR MOSFETs for its V-core and its SoC. There are quite some chips that I don't know what they do and I've never seen before. Like, there's some sort of South Bridge that has its own memory here. And it just has so many features that I couldn't tell you what they are. Like, there are some of these headers here that I've never seen before. Or this header. All of these I've never seen before. Like, what is this thing here? No idea. Then there's also a big USB on the board. As far as I know, this is for plugging in like an USB stick that carries the OS or something like that. And we have usual SATA. We have like GPIO pins, I think these are. I have no idea what kind of chipset this is. MC12-LEO. Very interesting. There's our main BIOS chip, I think. Then let's see, what else do we have? The I/O is really interesting. So we have, this is I think normal Ethernet, and this is like some of in and out. Not too sure. We have VGA and is this also VGA out? 2 USBs? I really don't know. So the backside also has some sort of programmable IC here. And very interestingly also, this has a PCIe 16X without a latch on the end. So never seen that also before. This is PCIe 4X, I think. There's another programmable IC here that is probably for this here, for this microcontroller. Then at the top side we have the usual 24 pin, 4 sticks of RAM. And we also have 8 pin CPU. And no idea what this header also does. So yeah, this thing is a big mystery for me. Never seen anything like this. And based on what the previous owner said, is that this has a BIOS issue. That he tried to flash the BIOS and he didn't succeed. There's a button here that I don't know if this is for power on or maybe for resetting or flashing BIOS. So we will be figuring that out. I also will have to see where I can actually plug a power button into this, because it's probably this that is already a power button, but yeah, I don't see the usual header. So I don't even know what kind of CPU this board supports. So we're just going to go with the 2600 now. So I also don't know if this needs ECC RAM or not, or if I can just plug my usual RAM into here. So a lot of things that we will figure out along the way. So let's see for the passive power consumption. 1.6 amps. That is very high. And the question is, does this board just automatically start or not? Let's see. So the CPU does have some temperature. So it seems like it just auto starts. But that is very low power consumption if this would be actually starting. So what I could already tell is that we're permanently stuck in PCIe reset mode. So if you can see on my tester, we're stuck with reset on, and the board automatically starts as soon as you try to power it on. So that is probably where we have to focus on. I need to look into the manual and see where the power button is located on this, and see if I can manually shut it off and on. And I will also have to take a look on if the previous owner meant the actual main BIOS or like the BIOS of this this sub, I don't even know, this is probably a processor by itself, of this processor. So let me educate myself a little bit on this board so we can move a little bit further with this. So quite some time has passed now, and now I've got a processor that is actually supported here, which is a 3100. Quite hard to see, but still. And now let's see what happens. So let's look at the power consumption. We have 1.8, 1.9, 2.2. And we're stuck at 2.1, almost 2.2 amps. And what I've noticed is that with these 2.2 amps, our CPU does get hot, but our PCIe reset is still stuck. So that pretty sure means that we have a problem with the BIOS. PCIe reset is often either applied by the BIOS or the SIO. I don't really know where the SIO is on this one, to be perfectly honest. Probably on the backside somewhere, because we have the chipset here, we have the BIOS here, we have these are Ethernet, and all of this is for the debugging. This is dedicated video, a dedicated graphics output or graphics chip. And I don't see any more big chips that could be responsible for that. So let's turn it off. So it has turned off. Let's see, is there something like an SIO on the back side? So I cannot see anything that would resemble a Super IO on this. There's one bigger chip right here that might be it. But it more looks like an audio controller, but this doesn't have any audio, so it probably isn't an audio controller. So what we are going to try to do is we will flash this BIOS right here. And this enables me to use this new tool that I've acquired. This is a programmer for EEPROMs, so everything that is like memory related you can program with this. And this is a Polish-based company that sell these. They make more stuff, but this flasher is insane from what I've seen. This thing has dedicated inputs, outputs via this cable right here, similar to the cable I made myself with the written pinout. This has a standard like adapter like here that you can, for the TSOP8 I think they're called, and the default that you also know from the CH programmer. And it's all powered by USB, so it's easier to just use one long cable for that. And what is also what I also provided is this clip right here. Let's open that up. If you look at this is a clip that has contacts that go out to these pins right here, which has very good resistance. So if you would clamp it onto something, it would hold probably very well. But I'm not too sure if this clip can be used for this package that we have here. But it might actually be able to use that package for it. So it does seem to attach very nicely to there. Let's see under the microscope if it looks anything close to actually holding on there. So if you look at this, it looks like it contacts it very, very well. Like it actually grips onto there pretty nicely. Like this could actually work. Interesting. But for the very first flash, I want to desolder this chip and want to program it via that. The standard adapters that I've been using with my CH programmer will also be able to use them with this programmer. So what I will be using is this adapter right here. On this adapter, I can solder this chip onto these pads right here. And I will do that, so I will get this chip off and put it onto here. So right now, the chip is on here. Does not look nice, but should work just fine. And with pin 1 at the top left, just like it indicates right here. So let's see in the software now. So right now we are in their own programmer. They have an own programmer for their tool that is free to use. And what we can do is we have a variable voltage setting right here, VPP off, where we can choose multiple different voltages. Oh, you can see I need to do a different capture. 1 second. So now you should be able to see this. Here you have a drop-down menu with all of the different voltages that this chip can have. And I'm pretty sure this is a 1.8 volt. So we are applying 1.8 volt to it. And now let's select the device. It's a flash. It should be 25 series. It's a wind bond. Let's see, does this thing can auto detect read ID here, 25 voltage VPP 2.5 read identification. Let's do 1.8 volts because this is my first time using this as well, so I'm trying also to find how this works. So I just looked up what chip we have. We have a W25256JW. So let's see now. I might have a bad connection to my chip. That is why we couldn't get the automatic one. So let's see if we can read this chip now. Okay, it seems like I was really dumb. You have to install drivers for this thing. So it recognizes your programmer and then you can install drivers for it. So, and I thought my soldering was the problem all the time. And yeah, you have to install drivers for this. Very good to know. They did send me a manual and they did send me the software in a special email only saying this. And my dumbass was just flying over too quick and didn't notice that you have to install drivers for it. So this one is definitely on me. So now we can actually, if we press identify the chip, you can read the identification and it tells you the chip right here. The W255Q256FW 1.8 volt chip, 256 Mbits. And yeah, if you press read identification, it just sets the VPP and everything just like you need. And now comes the most insane part. If you read to memory buffer, look at how fast this thing is reading. I cannot tell you how this is so much faster than the CHW. Like at the end of this, I will put in a timer how long this took. How long it took for this to read the memory of this chip. And we're already done. This is insane. Let's see. And there's some info. So let's now save that. So as a comparison, I have now the CH programmer in here with the 1.8 volt adapter, and it can also find this chip, have the information. And now let's do the big thing. We're going to now read this IC, and I will now go and grab a coffee or make some tea or something like that. Let's make it that you can actually see the progress bar. Yeah, so I will also be showing the time at the end, how long this took in comparison to the other programmer. And now it's done. This took forever. So let me close this, unplug the CH and plug it back into the new programmer that we have. So, this is not the only reason why I love this programmer, but this programmer also has the option to just choose the voltage as I showed you before in the top left here. So, no adapters needed, and you don't have to fiddle around with that. And the other very cool thing is, this has a protection via current also. This has standard 100 milliamps on each of the pins. As of protection, so for short circuit protection or similar things. So that if you short something or plug something wrong in, it won't just dump all the current it can, but it has a protection on that. And I can show you that protection also. Because here, overload protection. The standard is 100 milliamps. You can put it up to 200 milliamps, but it isn't recommended by them. And there you can even decrease the clock frequency. I've read that some chips get errors if you have this high of clock frequency that they provide. They should, I think these mainboard chips should all work very well, but there might be some very specific chips that need slower ones, but I don't think this will ever be something for me. Yeah. Yeah, it may be very helpful for in-circuit programming. Yeah. Yeah. So we will now erase the chip completely. So erase the device. Have you made a backup? Yes, we did. So we now erasing, and not only does the reading a lot faster, but also the writing is a lot faster. So another point for this programmer that we have here. So I will get you back into here as soon as this is erased. So now this chip is completely empty, and now I'll be flashing a new one onto here. Also, very good to know. This actually starts erasing it by itself if you try to program it. So when you program it, it erases it first, just to be very sure. So good to know that. So we've now been able to flash this chip. It has now the information on it. And this programmer has so many more things that it can actually do. Like, it has so many features that are just way over my head, to be honest, because I just do one of the simplest things with it, which is flashing BIOSes on simple EEPROM chips. So I cannot even tell you what this thing can all do. And just to clarify, I got provided this for free. I wrote them because I knew their programmer and I was sick of my slow programmer. So I asked them if they could provide this programmer for me for free, and I would use it on my videos. And yeah, because it was in the interest of both of us. It was in the interest of me because I just love that tool, because it's way faster and way better to use than the CH. And it was in their interest for me to introduce this tool to more people. So our chip seems to be nicely soldered on this side. Let's check the other one. Other side also looks fine. And let's clean up the area and see. So moment of truth. Let's see. BIOS is now flashed. Let's see. Does this still auto start? And it doesn't auto start anymore. That is already a good sign. And let's press the power button. And let's see if PCIe reset will be taken off or not. And it seems like it is not taken off. That is not nice. The CPU is getting very hot though. So we definitely do get CPU activity, but PCIe reset is still applied, and I cannot tell you why that still is. That is weird. So I'm pretty sure we're not getting boot as of yet. Let's see if it complains for missing memory, because that would mean we would get further than CPU, but I don't think we do. Or we maybe do get further than CPU, because now the current is actually not as high anymore as we had when the memory was in. So I might get a VGA cable into here just to be sure if that is maybe displaying. Now again, our power consumption is lower than we had before. Weird. Very weird behavior this board has. Very, very weird. Let's try a different CPU again in here after we flash the BIOS. If a different CPU will have a different behavior now in here. So the 4100, for example, instantly started when it was plugged into here. Let's see if we can manually turn it off. So the 4100 seems to not work in here. Let's get that out of here then. Let's try the 3000G. Let's see, this does not auto start. And let's see how this reacts. But the 3000G doesn't have PCIe reset applied to it. So this does behave a little bit differently than the other processors. If you see, PCIe reset is not applied anymore. Very weird how this one behaves differently. So none of my processors seem to work, but none of the processors ever went so far with the power consumption like the 3100. So I think it is our best bet to get this to work, which makes a lot of sense if you think about that. This is the only actual processor that is supported for this board. So I would go ahead and try to work with that. The problem I see right now is that we have auto start again on this. So I don't like that. So I will definitely remove the CMOS battery and see if there's a clear CMOS header somewhere here and try that. So let's see, after resetting the BIOS, it does start up by itself. Not having the CMOS battery. Let's see, does it turn off? So this board so far is really difficult to diagnose for me. I've been going back and forth with multiple processors, and also I've been trying now with a graphics card and also different RAM, because I really cannot get a lot of information out of this board and what state it is actually stuck. So even trying with the DDR postcard and trying with the postcard in the PCIe slot, I really cannot get any information out of this, what is happening and at what point it is stuck. So there might be a different BIOS that I can try on here, and I might do that. But one more thing that is very often the case when you have resets stuck, that the SIO has some sort of problem, that maybe a signal is missing or some component is knocked off. So I will be going under the microscope and I will be especially looking at the backside of this board, and I will see if I can maybe find a knocked off component on this one. So I was quite stuck with this mainboard. So I was getting into contact with the previous owner, and he told me that he wasn't actually flashing the main BIOS, but the BMC BIOS of this. And that got me questioning what that is. So I headed into the manual of this board. So I went into them and I noticed this has a LED for the BMC firmware readiness LED. And it has an on state, which means it's initializing. Blinking means it's ready, and off it's AC loss. Let's have a look at our board. So let's apply power to it. It auto starts. And look what the LED is doing. The LED is solid on, which means it's initializing the firmware of our BMC, but it never gets to finish that. So it should be blinking if that one would be working. So it seems like we have a problem with our BMC firmware. So one more thing I want to show you. This BMC is an ASPEED AST2500. This is connected via the LPC directly to the CPU and is for MLAN, VGA, and the communication port. And this seems to have an integrated onboard graphics. So it has integrated graphics for the AST2500. Very, very interesting. So a 2D video graphics adapter that only... Yeah. So now I was going closer around the BMC for itself, and I noticed that there's a single big chip here close to it that has a red dot, and dots like that mean they have firmware programmed on them. You see, this is memory for it. This is probably for the graphic memory. And there's BMC FLH written right there. So this probably holds the firmware. This is a 512 Mbit chip. Okay, I have a really hard time focusing, but you get the gist. We will need to flash this chip to get the firmware ready of this big chip so that that LED turns from solid into blinking. And this is the chip that we're currently dealing with, an MX25L51245G. And if we go to the pinout of it, which is right here, we can see we have the big package, we have the 16-pin SOP, and I do not have an adapter to flash this. I don't have anything that this could connect to. So what I was thinking, and I actually got to tell you, I don't know which of these pins are necessary for flashing. I could, like, a few I definitely know. Yeah, like you need VCC and you need chip select, you need SLK, so clock, and you also need a data pin. But I'm not sure what is the minimum required amount to actually flash it. So what I'm thinking about doing is I will use this layout here, which is the 8-pin version of it, and I will be connecting to these pins here that are corresponding to it. So I will be connecting pin 1 of my flasher, of my programmer, to CS1, pin 2 to SOI1, which would be here pin 8, and chip select is pin 7 here, and then pin 3 VP SOI2 would be this one, pin 9 here. Then we have ground. Then next one would be the number 5. This is this one. 6 is clock. 7 is reset, which I would be connecting here because there's an SOI3. Is there? No, there's not. So we connect it to reset. Oh, there is. But this is probably not connected. So we probably will connect it to reset. And then VCC, which is there. Yeah, so we're probably going to do that. I will do that off camera, so I don't mix these up. And then I will show you the result of it. So my spider creation is ready. This took about like half an hour to do. So I've connected 8 different DuPonts onto here, and these are all connected via the DuPont extension that go into our programmer. So these connect into our programmer, and now the big question is, did I do it all right? And can we read the firmware off of this one? So no one move, no one breathe, so that everything stays connected. And yeah, let's hope for a miracle here. So let's see and hope together. This is a 3-volt chip, and it is an MX25 series. So let's accept that and let's read. Operation cancel, too much current. Okay, this might be a problem of that we are programming it in circuit. So let's see. Okay, let's go for 3 volts. And we cannot find it. Let's go into 3 volts here. And I cannot get the identification of this chip. So I had to switch over to the CH programmer because I'm doing in-circuit programming, and I was told by the company of the other flasher that if there's too much current being used for in-circuit programming, it won't work. So the CH just gives it all the current it can. So yeah, sadly that we can't prevent that, but we're using the CH programmer now, which means this will take an eternity. But we found our chip that we need. This is very nice. So let's get to reading this chip, which will take even longer because this is a 512 Mbit chip, so it stores even more information. But let's get that information off of here. And just to clarify right now, the other programmer that was provided to me, it can flash that chip. But the big problem is that the 3.3 volt line is actually the auxiliary line, and it would supply the auxiliary line for all of the main board. So it supplies it to, basically turns on the 3.3 on the main board, and the programmer is limited to 200 milliamps. That's why we can't flash it in circuit. So I've ordered myself some adapters so that next time we can just desolder the chip and put it onto an adapter and then flash it with the actual new flasher that we have, and it will be way faster and way better. But something I learned, that I need another tool. My bloody programmer crashed while doing it, and now I have to read it again. You know, the CH is a really reliable good programmer, but sometimes it really gets on my nerves, especially when it takes so long. I really have to get some more adapters for the other programmer, so I can just desolder the chip, throw it onto an adapter board, and then connect via that. So I was able to read the content of the chip. Now I dumped it already. Now I'm going to erase the chip and then flash the new software. It's finally done programming. I kid you not, this took 20 minutes to program and verify. I cannot believe it. I'm so ready to dump this CH programmer. Like, seriously, get this thing off of me. Cannot believe how long this took. Hopefully that has helped us and will now make the board work. So, let's try to boot this thing up. So, big moment of truth. Let's see now. So we're turning on, and let's see if this LED will go to blinking at some point. Did I just hear the speaker? I heard something from the speaker. The speaker is trying to talk to us. Let's give this some time. Oh, you see? It's blinking. The LED is blinking now. That means we have initialization via that. I didn't get a beep yet or anything like that for like posting, but let's leave it. Let's see if it does anything different. I will be, however, connecting this VGA onto here. So our power consumption went a little bit down. Don't really know how I should interpret that. I don't have any reaction on my keyboard or anything like that. I really cannot tell you in what state this mainboard is currently. It's hard for me to tell. I kind of still want to leave it at least a little bit, but I might want to see if we can oh, this now has a function as well. Whatever this is reacts now. See? Oh, the current just jumped up way higher when I did that. Oh, and we have boot. I cannot believe it. I cannot show you. Only I can show you like this. Oh, we have a Gigabyte splash symbol. I cannot believe it. This thing is actually on and working. Oh, that was our problem. The firmware of that chip, and now it's actually working. I cannot believe it. I am so happy right now. And I also have indication on my keyboard as well. Let's see if we go into BIOS here. And yeah, there we go. Because this is connected via VGA, I don't have a way to capture VGA, so we do have to do with this right now. So the board is restarting currently because of the missing BIOS files, because we were clearing the CMOS. And there it is again, booting up, and let's see a BIOS screen. Let's have that. come on any second now. Oh, I have to go into BIOS myself, I guess. Entering setup. Okay. And there's the BIOS splash screen. I am so happy now that this works. Oh, thank the Lord. So, I've now added an M.2 SSD. And this is basically the only test I can really do, I think I will do for this. To see if this actually boots into Windows. And then there's nothing really much more that this board can do or should do. Like, I could maybe, let's also populate the RAM. Let's do that. But that's basically it. So, let's turn it on. And let's see for it going into Windows. I won't test a PCIe card or anything in here. I'm happy that it boots up because we know what the problem was. It was the firmware of the BMC that was actually faulty. So, yeah. Let's just see that we boot up with all of the RAM in here. And now the BMC is initialized. As you can see, now it's blinking, which means we should have post anytime. And with that, our board has booted up. And as you can see right there, we are in Windows. So that is all that it was important for me now to see. And yeah, I gotta say I'm very happy with this repair. It was quite interesting. First flashing the BIOS of this chip. And then reading up what this BMC actually is. This seems to be a Super I/O chip and has integrated graphics and is responsible for multiple things like the LAN, also like I showed you in the manual of this. And yeah, thanks again very much for the programmer. And I will be getting adapters so I can next time, instead of trying in-circuit programming, I will just desolder this chip here and then do it here, because it will be so much faster for reading and writing and erasing the chip. It's just so much better to use this thing. And I'm very happy as soon as I can dump that CH programmer. Like, it served me well, but it's time to move on and to have something more mature like this one. Thank you very much for providing it. I will link it in the video description also, that I will be using this now. And yeah, I hope you learned something. This was something very new for me as well. And first time I flashed a flash chip that has this much memory and that is this size. And I'm very happy that it worked. And this board will probably go into my own server station. So this will be used as a local server for my local network. So thank you very much for watching. I hope you enjoyed the video. I hope you learned something. And see you in the next one. Bye.